we'll have a brief. We'll start with this, where the layout of the problem and adding the data, preparing data, creating new variables, then how to do a descriptive data analysis, and how to work out with the SPSS output. So quickly move on to the history of SPSS. So if you remember, the SPSS as such, the first version was released in 1968. You don't know who are these people, and you'll wonder why SPSS. So the first version was released in 1968. Uh, Now remember, Normandy and Hull, these two people who developed this software, and you believe it or not, they are not from science background. They were not from computer science. They are not from mathematics. You believe it or not, they are the professors of political science. So two professors of political science, they developed this what you call software, and now over the time it's been what you call revised and revised. Now we are in the version 28. Maybe version 28 might release next year. So IBM SPSS Statistics has got what you call 28th version now. Started with the first version. So the advantage of SPSS is you can analyze and better understand your data. Even complex statistical issues can be done in no time, and the user-friendly interface is very good. You'll be knowing one and one, then later. Then the data collection, data analysis is very fast, and if your processor is what you call with the super speed, it can do it in seconds. So, and you have high accuracy as your data entry is done checked twice, and you can involve that is in quality decision making. Then you can integrate with the Python and R programming other softwares also. So once you do that, you can have added analysis for that. Then you can use a large data set. That is a more important thing, where a large data set can be utilized. Thousands of data you can enter in one sheet, and you can get the data analysis done very fast. And DFs are calculated ready-made, and you have what you call ready-made significance levels. Everything is under a user-friendly interface, and surprisingly, if you find the softwares have got usual softwares have got a single window, SPSS has got 4 windows. So starting with the data view, I'll show you that later, variable view, output view, and syntax view. So all these four variables will make your job easier. So how that windows would look like? See now, if you see the first window, this is what you call, this is called as data view, where you can see, which I'll show you later anyway, where the data editor, where you can bring the data here. So that's called as data editor, where you can bring the data from different softwares like Excel and other things. You can import the data, or you can directly type the data. That also can do. So it has got a multiple functions where it can access the data. So once you get the data, then you can generate the tables, and that tabling is called as what you call output view, where whatever the tables have been generated, it's called as output view. Sometimes you have to define your data in the background, then it's called as variable view. So that also would be there. And whenever you want to know what you call what is been given in detail, you can go for a syntax editor. So you have data editor under the data view and variable view as a 2 screens, output viewer as a 3rd screen, and syntax editor as a 4th screen. So you have 4 what you call windows, and don't worry about the file types, they'll be auto. So they take care of the saving by itself. So we don't have to bother much, but these are the program windows. Basically I have got 4 windows. That's what you have to remember. And you can do a lot of what you call work jugglery here. You can choose options, several options. You can define names, you can record things, you can display commands, you can do a lot of things. That's why it's called as a highly user friendly software. Then how to add the data? So you can use the syntax to read the existing data file. You can inline data with the syntax file. You can use the text import. You can data entry directly into the SPSS data editor, or you can import from Excel also, or even from a Word file. If it is formatted text, still you can get the data to SPSS. Now, how to load the data, you can read that. And for you, because for our time constraints, we are not doing much. Remember, for each and everything, YouTube videos are available. So you can use the YouTube video for using SPSS, where YouTube videos are highly useful. So all this loading the data and all can be step by step you can do. Then you can define them. You can do a lot of what you call jugglery there. That's not a thing there. Again, you can load the data and with the syntax and other ways where you can type or whether you can get all that. But remember how to prepare the data for analysis. Now, this is where you have to start with the variable formats, then variable labels, then value labels, then missing values, then copying data properties. So this I'll do what you call in one of the data file. Once I give the brief introduction over this. So we have to enter the data, we have to define the data, then we have to execute the what you call analysis. We'll see how it will be done. Formatting and all, I'll show you how to be done. Formatting your variables, that also will go to the second level. Creation of new variables also we do. Recoding the variables again. Computing new variables also can be done. You can use some mathematical expression. Using some mathematical expressions, you can generate new tables. Suppose you want to calculate an index, you have to use some what you call formula. This formula can be used in the numerical expression, and you can generate a new what you call column where you can save a lot of time. So there are so many things. And under descriptive statistics, you have got frequencies, descriptives, crosstabs, and mean values, which I'll show you how to do it. Then the frequency, how to generate, I'll show you, because now I will show it's of no use. Then how the output would come, that also I'll show you. So there are several such things where we are going to talk about it. Cross tabulation, the means output, how to edit them. This one I'll show you that. Then export, so that you can export into Word. All that we will be trying to do as much as possible. Now kindly open your Excel sheet which you have already opened. Have opened your Excel, have opened your SPSS output. Have opened your SPSS output. Please open your SPSS article file, which I've already opened. Can you see the SPSS screen? I shared the screen. Can you see the screen?
Yes, sir.
With a spreadsheet?
Sir, yes, sir.
Huh?
Yes, sir. We can use it.
Okay, for your profit, I'll increase the font size so that it will be much more larger in nature. If you're watching through mobile, it could be a small screen. So what you're seeing now on the screen is the data view. See, on the down, I click variable view. That is showing the another screen which is slightly different. So these are the two things where it's required for data entry and defining the data. So suppose I have a data. For example, I have data for 5 boys and 5 girls. So when the data is there for 5 boys and girls, so that suppose I open what you call data like this. So we have to create 2 columns. Suppose you have what you call gender as one variable, scores as second variable. How we are going to do? So I double click the first column. So it goes to the variable view. I type it as gender. I type it as gender. Now it asks what type of data it is. Now you see these are the types of data available, whether it's a numeric data, comma, or this one. Since it's for me, it's a numeric data, and it asks about the width of the data, decimal places. I am not using any decimals, so I'll make it 0. Then I say okay. Then it asks values because I have to define gender now. So what I do is I define one as male, you are seeing there, 2 for female. Are you getting it? So how I'm going to do is I repeat, I type it as gender because I want 5 males and 5 females to be what you call recorded the data. So I want to define them. So I go for the values. So value 1 would be 1 for male, 2 for female. So this is independent variable. So I have defined in the background what is 1 and what is 2. Then I say their scores. What are the scores in one of the subject? And I don't require what you call any width or decimals, and I'm not defining them because they are the continuous scores. So the remember in SPSS, the dependent variable will not be defined. Only the independent variable will be defined. Now, are you clear up to this? Now I go back to the data view. See now, already the columns are created. I have not typed here, but since in the background I have created, they already seen there. As I said, I have 5 male data. So I type 1. So 5 times I type 1 and 5 times I type female, so that I'm setting the data setting for the data entry. So I have given option for 5 males and 5 females. Now I have got a set of hypothetical data. I just type it. So this is the male data. So now you have seen how I'm entering the data. What I'm doing is I'm directly entering the data from SPSS software itself, within itself. You can bring the data from outside. You can copy paste, you can import. All those wizards are given in the PPT. So you can later refer it how to bring the data inside the file, or you can directly type. Now you are seeing the scores. Suppose I want to know all the measures of central tendencies, measures of variabilities for the scores column. Forget about gender. Suppose you have got the scores like this. I want to know the measures of variability, measures of central tendency, what is the maximum, what is the minimum, everything. So to get a complete descriptives, make a note in your command style, write down to get complete description of a set of data. From the menus, choose analyze. From the menus, choose analyze. Go for descriptive statistics. Go for frequencies. If you are not done the command set, again I'm repeating. From the menus, choose analyze. Descriptive statistics highlight. Go for frequencies. Now, if I do that, I get this kind of a box. So look into the screen. You have 2 boxes, major boxes. One is on the left side and one is on the other right side. Remember the left side box, the data which gives the idea that what is being entered. The right side box, what we have to bring it. So you can either directly click that scores to the variable column, or you can drag like this. So either way you can manage. So I'll take the scores as what you call as my variable, and I take it to the right side called as scores. So what all I want, see there is a option called as statistics. You can click that. So now it asks what all you want. So I want a mean, I want a median, I want a mode, I want a sum, I want standard deviation, I want variance, I want range, I want minimum, I want maximum, I want standard error, I want skewness, I want kurtosis, I want quartiles, all the 4, I want cut points for every 10, I want 30th percentile. Now imagine how many things I have highlighted. So all these things I want, starting from measures of central tendency, mean, median, mode, and sum, and measures of variability, SD, minimum, maximum, standard error, range, variance, in between quartiles. So I have highlighted all of these things for a column called as scores. Now you see, I click continue. How much time you would think that analysis would require? Okay, now OK signal is highlighted. I just click OK. Are you seeing the screen?
Yes, sir. Yes, sir.
Is the output is generated?
No, sir.
Okay, because it's the output, it will go to a different screen. Okay, now I'm sharing that output. Are you seeing that now?
Yes, sir.
Now you see, mean is generated, standard error of mean is generated, median is generated, mode is generated, standard deviation, variance, skewness, standard error, kurtosis, minimum, maximum, sum, and all the percentiles. Now it taken only few seconds to perform this analysis. Now remember the power of SPSS, how quick it is. So note down the commands. Note down the commands for SPSS generation of what you call descriptive statistics. Again, I repeat, from the menus, choose analyze, descriptive statistics, and go for frequencies. I'll reset everything. So I want a descriptive statistics for the scores. I take the scores into right side into variable point. I click statistics, the option which is available. I highlight mean, median, mode, sum. I require skewness and kurtosis. I require standard deviation, variance and range. I require minimum, maximum and standard error. I require all the quartiles. I require cut points for 10 equal groups. I require a percentile for 30. So many calculations I've asked for the software add. So now I've highlighted almost all the options. I'll continue. Your ready signal is there. And I might require a chart. Let me see, I go for a bar chart. Let me see how it looks like. And I'll continue. And I'll click. See here, again, I'm generating second time. You have all the measures of central tendencies, all the measures of variabilities, all the cut points, including a graphical presentation. Now remember how quick it is. If you want to do these calculations, for example, whatever highlighted, it will take you a few hours, but SPSS can do it in few seconds. So that is advantage of what you call generating what you call the descriptives out of a data. Now I go back to my original screen. Are you seeing the original screen now? Are you seeing the original screen with the data
Yes,
set?
sir. Yes, sir.
Okay, I'll add the third gender. For example, I'll add the third gender now, called as TG or the transgender. So I'll add only 4 genders, transgenders. So that will be a third category. And I'll add scores. So now you have got a data set, but now I want to have frequency and percent. Now so far we generated for the direct data, we have generated all the mean, median, mode, and measures of variability like standard deviation, maximum, minimum, and all. Now I want to know how in gender classification how many are there. So to do that, again I go for the command called as from the menus, choose analyze, compare means. Okay, since we are going for frequencies, from the menus, choose analyze descriptive statistics with the frequencies. Now I go for gender, or I reset everything. So I go for gender. I want to know the gender classification. Now remember, this looks very small for you. It's very easy 554. But if you have got hundreds of data, like 300 data or 400 data, now that is not so easy to calculate. So in such cases, what we do is we use a software. Now I have taken gender and I want to know gender classification. What is the frequency? What is the percentage? So to do that, I repeat again, from the menus, choose analyze, descriptive statistics and frequencies. So I click that. So I take gender into the variable column. I want a chart also to look like how this, what you call, chart looks like. I go for histogram. I'll continue and I click OK. See now, are you seeing the, what you call, the output screen? Are
No,
you seeing
sir.
the output?
No, sir. No.
Okay, I think now you should be able to see.
Yes.
Huh?
Sir.
Are you seeing the output screen now?
Yes, sir.
Okay, now you
Yes,
see
sir.
there is a total of, I'm highlighting total of 14 cases, out of which 5 are males, 5 are females and 4 are transgenders. See their percent, 35.7 each of male and female, and 28.6% of the, what you call, transgenders. There is a valid percent, there is a cumulative percent. If you want, you can add or you can delete. And now you see the graphics, 5 males, 5 females and only 4 transgenders. Now it looks very simple when we have taken only 14 data. But remember, when you take thousands of data, the same amount of time is taken for calculation and it's very quick calculation. So that is why the advantage of software is like that. So are you clear about generating central tendencies or descriptives and frequencies? Anybody is having doubt, please let me know. Anybody is having doubt? Generation of descriptives, generation of frequencies, generation of percentages, where it's basically we talk about descriptive statistics. If you have no doubt, let me continue next because we're running short of time. So I'll go back to the screen again. Okay, I'll go back to the original screen now. Now we'll slowly move on to the t-test and all. So when you talked about t-test, remember before getting into the t-test, now can you browse through all the commands there? If you see file, all the commands like any Windows software, it will work. So for example, if it's a file, new, open, all the things are there. Go to the editing part, you can edit the data. You can have data, how to manage that, sorting, then converting data into categories, everything can be done. Transformation of data can be done. Analysis, a whole range of analysis, and within that you have got sub analysis like this. Now imagine how many things are there under each. So there are several tests are available. Then a series of graphical representations. See now, these are the graphs which you can generate, and their utilities, add-ons are there. Then there is a help file which is a very important. Suppose you are using SPSS, I would advise you to go for the tutorials first and statistics coach. So it gives a lot of idea regarding what you call how to do statistics in SPSS by referring to help file, especially the statistics coach. So get on to the statistics coach, where a statistics coach can give a lot of what you call information regarding the way you are going to conduct the statistics. So that is more important. Now having all this and all the commands work exactly like that: control save, control V, control P, control D, wherever the whatever the word commands you are going to use, all that print, save, copy, cut, all those commands are the same commands are given for SPSS. So that is why you can do a lot of things, but that you can learn eventually. And that's why I advise you to start with YouTube videos on tutorials. There are several tutorials are available in YouTube to perform many tests, and they'll interpret also. So that's the idea. Please go ahead with that, which will be very good for you. Then you come back to now main screen. Now I want to do a t-test. All of you, please listen. I want to do a t-test looking into the data. Now t-test, I said it is for two groups difference. So once we say two groups difference, how we are going for it? So to do a t-test, write down the commands. All of you look into the screen. From the menus, choose analyze, compare means, and independent samples t-test. I'm keeping the option open there so that you can note down the commands. All the highlighted portions once. From the menus, choose analyze, compare means, and independent samples t-test. So I click that. From the menus, choose analyze, compare means, and independent samples t-test. I click that. Now you see there are boxes are there. It asks which is your test variable, which one you want to test. I want to test the scores, which this I'll bring into the test variable. Then what is your grouping variable? It asks. My grouping variable is gender. Again, I go back. It asks, as I said, on the left side, you find the variables which are already entered in the file. But in the test variable, you have to specify. The dependent variable for me here is the scores. The grouping variable for me is the gender. Now, it asks what are the two groups you want to compare, whether you want to compare male with the female, or male with the transgender, or female with the transgender. So what I'll do is I'll compare male and female first. So it asks what is our definition? For males it is 1, for females it is 2. So I define groups 1 and 2. So I needed a comparison between groups 1 and 2. That's nothing but males and females. So I'll continue that. Now my OK signal is highlighted. So I'll go back again. I'll cancel everything. I'll repeat again. You want to do a t-test. From the menus, choose analyze. Compare means independent samples t-test, where gender is taken as a grouping variable. I want to compare a male, that's a code of 1, with a female, that's a code of 2. So 1 versus 2, I want to compare against a dependent variable called as scores. It's already highlighted. I'll click OK. Now, you are not able to see the screen. I'll share again the results. The results are already come. See now, this is how the results have come. Males have, can you see the results now?
Yes,
Can
sir.
you see the results
Yes,
like
sir.
t-test,
Yes.
group statistics and all?
Yes, sir.
Okay, now you see all the descriptives in the first table. Males with the n, what is the n we have used? Their mean, their standard deviation. Females, their n, their mean, their standard deviation. And down there is a t value and there is a significance or the p value. As I said, the p value is shown exact, not at 0.1 or 0.5 or 0.001. It shows the exact significance level. So it is significant at 0.012 level. As I already said earlier, if your p value is less than 0.05, then it is significant. So here you are going to find that p value is significant because it is less than 0.05. Now compare the mean values of males and females. Males have got a mean of 26.2. Females have got a mean of 37.2. So you can definitely say that females have got higher scores than males. Is it making sense? First you check the t value, then you check the significance. Significance is 0.012 level. Then come back to the mean. The males have got a mean of 26.20. Females have got a mean of 37.20. So definitely you can say that females have got higher scores than males because it is significant. Any doubts? Feel free to ask doubts. If you have no doubts, we'll go further. So now we have done a male and female comparison. Now we can go for furthermore comparison by independent sample speed test. I want to compare females and transgenders. So I change the groups by defining them. Instead of 1 and 2, I define as 2 and 3 because t-test does as difference only between two groups. So I continue. Now the comparison is 2 and 3 with the scores. So I click OK. Are you seeing the screen now? Are you
Yes,
seeing
sir.
the okay? Are you seeing the output screen, right?
Yes, sir.
So now you see gender, female and TG here. If you see the cursor, the comparison goes for now female and TG with the N of 5 and 4. Now it says females have got 37.20 mean, TGs have got a mean of 18. So your t-test says there is a 0.002 level of significance. That means females and transgenders differ significantly. So likewise, you can do any comparisons across any two groups, 1 to 2, 1 to 3, or 2 to 3, or even if you have got 5, 10 groups, you can specify the groups and you can go for t-test. Now that's about independent samples t-test. We'll start with the paired samples t-test. So in paired samples t-test, again I'm coming back to the sharing of screen. So now, as I said, I have a data of pre-test and I have a data of post-test. So I randomly enter 5 data there. These are the mathematics errors done by the students after training. The errors are like this. So you have a design of now 2 more columns. Are you seeing the sheet, the data sheet? Are you seeing the data sheet now?
Yes, sir. Yes, sir.
Okay, you have got a pre data, you have got a post data. See, now data entry goes in a different way because now they have to come in a different columns. So now we have got a pre-test and now we have got a post-test data. But remember, N must be same because it's on the same individuals. So you have got a pre and post data. So that's why it's called as paired samples. Sample is paired for a variable. Now we want to know whether errors have been decreased from pre to post data. So we have got a pre-post design and we have to apply a paired samples t-test. So to do that, what I'll do is I go to analyze. So write down the commands if you want to do a paired samples t-test. From the menus, choose analyze. Compare means paired samples t-test. See now. From the menus, choose analyze. Then comes for compare means. Then go for paired samples t-test. Again repeat. From the menus, you choose analyze. Compare means. And in that you choose paired samples t-test. Click that. So now you get, see now the format is different. It asks, the software asks, which is the what you call variables you want to pair it. So I say pre data, I take it to the variable 1 and I take post data to variable 2. So I've taken pre and post data. You can check that. So I can reset again. So I can go back from the menus, choose analyze. Compare means paired samples t-test. So in that I highlight, I want to compare pre-data with the post-data. I just click OK and I share the result output. See, now this is the results which you can see. Are you able to see the results? The highlighted the t-test, pre and post. Are you able to see?
Yes, sir.
Are you able to see the data?
Yes, sir. Yes, sir.
Okay. Now you see in the pre-data there were 23.40 errors were there, but after training, when the same test was given, it was reduced to 5.6. Now there is a reduction of, you go for mean difference here down, 17.80 scores were reduced, and that is found to be significant at 0.003 level. So you find a t-value of 6.278 with the significance level of 0.003. So that means what? The training or the coaching you are given to reduce the number of errors in mathematics have been significantly reduced from 23.40 to 5.60. So that means your treatment or the coaching is highly effective. So that's where what you call, we do a paired samples t-test. Then we'll move on to the ANOVA. So I'll go back to again our data sheet. So in the ANOVA, if you see there, I don't have to enter the data. What is the condition to use ANOVA? What is our prerequisite? What is our prerequisite to use ANOVA?
Analyze covariance.
Eh?
Analyze covariance.
Minimum of how many groups should be there?
Group.
To apply ANOVA, how many minimum groups are required?
2 groups. More than 2 groups.
Yeah, if there are 2 groups, we don't do ANOVA. If there are 2 groups, we go for t-test. So here, what we are going to do is, we are going to perform ANOVA now. So already I have got 3 groups. Now you see, gender is split into 3 levels. So since the gender is split into 3 levels and the scores are already set, so I go for ANOVA. So to perform ANOVA, so what you have to do is, again, write down the commands. From the menus, choose analyze. Compare means and one-way ANOVA. I already highlighted the columns. From the menus, choose analyze. Compare means and one-way ANOVA. Note down the commands, those who are interested to learn this. Again, I go back. From the menus, choose analyze. Compare means and one-way ANOVA. Click that. So if you click that, you are going to get the prompt like this. See the prompt on the left side, it's already written as one-way ANOVA. So I want gender as a factor because it will not ask grouping because it's any number of groups. So it will not ask any grouping part. Then I highlight scores as my dependent. That's also required. Then I ask options. I go for options to generate a descriptive statistics. I go for a post hoc test to see whether there is a difference and which are the groups are significantly different from each other. So for that I use a post hoc test and I continue. OK signal has come, but for your reference, I'll go back again. From the menus, choose analyze. Compare means and I go for one-way ANOVA. So I ask gender or I push gender into the factor. I ask scores into the dependent list. I go for options to highlight descriptive statistics. I continue that. I go for a post-hoc test. Maybe I'll select Sheffie's. I'll continue further. So everything is highlighted and I go for OK signal. So the output is already generated. I'll just share it. So now you see the ANOVA table. So now you see the scores for male, female and TG with the mean, with the standard deviation, with the standard error, with the minimum, with the maximum, followed by ANOVA table, source of variation, degrees of freedom, mean square, F value and significance. See, that is advantage where software gives ready-made significance level. Software calculates what you call degrees of freedom. So everything is done by the software. So that's why it's very accurate. And later, now it says your F value is 17.706 and significance is 0.000 level. So it is highly significant. That means there exists the difference between males versus females versus transgenders. That's the first level of your interpretation. There is a significant difference in the scores between males, females and transgenders. That's the first level. But which group is different from other? You get to know from what you call a transgender comparison with the male and female. So now you see here under scores, these two are same, 18 and 26. That means what? There is no significant mean difference between transgenders and males. Only females have got higher score and they are different from others. So your idea is here how to interpret is, if at all ANOVA has come significant, it is because of females who are having higher scores compared to males and females. But between males and what you call transgenders, there is no significant difference. Are you getting it? Or is it becoming complicated? Are you getting it? Or you want me to explain again? I know it's a bit technical, but you can learn. So I'll explain again. So when we perform ANOVA, so you generate the tables like this. You have one table for descriptives, one is table of ANOVA, one is multiple comparisons. So in what you call mean comparison, you have male, female and transgenders for all the types of what you call descriptives, starting from N, mean, SD, minimum, maximum. Then you get a mean what you call ANOVA table and it says significant or not. Then you have post hoc test which says no difference between transgender and males because they are in the same group. Only females are in different subset. That means if the difference at all it's coming, it is because of the females having higher score. So this is where you interpret the ANOVA. Now we'll slowly move on to some other tests. For example, correlation. So to generate a correlation coefficient, the commands are slightly different. So what are those commands? So note down the commands to generate a correlation coefficient. From the menus, choose analyze. I think I'll get back to the data screen. Are you seeing the data screen? Jay Prasad?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So now I want to do what you call a correlation between any two scores. Okay. Marks in English and marks in psychology. I just type it. So I just randomly type some scores. Okay, now I have typed the data. You have got marks in English and marks in psychology. So I want to generate a correlation between those who score high in English, whether they score also high in psychology. So I need to generate a correlation coefficient between these two scores. So after the data entry, you select the commands now. You can note down the commands for correlation coefficient. From the menus, choose analyze, correlate. See, there is a vertical signal is there, correlate, and there's another option called as bivariate. So from the menus, choose analyze. I do it again. From the menus, choose analyze, correlate, and bivariate. So click that. So it asks which of the things you want to correlate. So I want to correlate English marks with the psychology marks. I want to correlate with English marks with the psychology marks. And down, if you see, there's a Pearson correlation, there's a Spearman correlation. So because of the time constraint, I'll generate both of them, Pearson as well as Spearman together. And you see how the correlation will be generated. But before that, I reset everything. I redo everything. So you have entered the data for English and psychology. And I want to generate a correlation coefficient. So what I'll do is I go for analyze. I go for a correlate. I go for a bivariate correlation. I click that. So I highlight English as well as psychology for correlation, which is on the variable side. I needed a Pearson correlation and simultaneously I generate a Spearman correlation. Don't think that they'll come together. They'll be in separate tables. So there is no mixing of things. So I highlighted, it asks the options like whether you want a mean and standard deviation. Yes, I want a mean and standard deviation for both the series. Now and it asks whether you want to flag the identify with the stars. Yes, I want to do that. So everything is highlighted. Your OK signal is highlighted. I click OK. So again, you are not going to see what you call the screen right now. I'll show the screen. Okay, this is the results. So now you see, since I asked mean and SD, for English scores 41, psychology scores 48 mean with the SD and all for 88 people. See the correlation, English to psychology, the correlation coefficient is 0.588, which is non-significant because this 0.125 should be, if you want to get a significance, it should be 0.050 and below. Since our significance is 0.125, we say it is non-significant. So that's the idea. We don't say it is significant. We say it is non-significant. There is no significant relationship between scores in psychology versus scores in what you call English. So that means one scores would not determine the other scores. So there is no dependence of one scores over the scores of another subject. So that is why you can see a Pearson's correlation on the parametric side. But on the non-parametric side, you can see Spearman's row, the correlation is reduced, significance also reduced. So the correlation here is now 0.575, whereas in the case of Pearson's correlation was 0.588. But in either case, the correlations were non-significant. So that is the idea. So you can generate even the correlations. Then apart from correlations, if you want to see the regression, that also you can do. I'll do it in the same screen. So I want to generate a simple regression, how the relationship would be between English and psychology, and whether can we have a scatter plot. Yesterday somebody was asking, and whether we can have a correlation for that. So we'll try that. So with the regression, I go for a curve estimation. And what I do is, again, to generate a regression, again, I'm repeating the commands. From the menus, choose analyze, go to regression, and go to curve estimation because it's a single correlation and single regression. Now, so again, I repeat, from the menus, choose analyze, regress, and curve estimation. Now it asks, okay, what are the independent variable and what is the dependent variable? I keep English as variable as independent, psychology as dependent variable, and all the defaults are highlighted. I want constant, I want a plot modeling, I want a linear regression or a simple regression. So everything is highlighted. So I just click OK. Now, are you seeing the scatter plot?
Yes, sir.
Now, remember, the scatter plot says there are scores of English. Against that, each candidate of scores of psychology have been highlighted. Now you see the equation, model summary and parameter estimates. The R square is given, which is exactly what you call square of a correlation. And if you go for correlation up, yesterday I was telling it was 588. If you see the correlation 588, so if you square it, you get 0.346. And it says for one score increase in English, there is a 0.34 scores of increase in psychology scores. So that is the idea. So there is a one score in English because if you increase the score by one, there is a corresponding increase of only 0.34 scores in psychology. So your equation is equal to y is equal to 34.199 plus 0.347x. So this is where you can derive a equation which yesterday I showed through descriptive statistics. So even a regression can be used, and it is so easy through software SPSS. Now these are the few simple things which you can do. Let us go for chi-square test, so that is also important. So I'm talking about chi-square test because we are running out of time. So in chi-square test, what I'll do is opinion regarding ban mobile opinion. So yes and no. Two opinions have been elicited, yes and no. I'm directly writing the data. So these are the opinions have been generated, gender and mobile ban. So suppose I want to know only mobile ban, how many are there for and how many are against. So for that I can check through a chi-square. Forget about the gender now. A simple chi-square I'll generate. So while generating the simple chi-square, what I'll do is I start with the analysis. So this is to generate a chi-square. Note down the command to generate a chi-square. From the menus, choose analyze. Go to non-parametric test down. From the menus, choose analyze. Go to non-parametric test down. Furthermore, legacy dialogues. And if you see there, chi-square. Again, I repeat, from the menus, choose analyze, non-parametric test, legacy dialogues, and chi-square. So I click that. It asks which is the test variable you want to test. So I say the ban mobile responses. So I've chosen ban mobile responses, whether there's a difference between yes and no responses. So ban mobile is a variable which we are going to find out. So what I do is I highlighted the ban mobile variable into test variable list. So I highlight or put into test variable, and already OK signal is highlighted. I just click OK. So I'll share the results now. Are you seeing the result sharing? Are you seeing the result share? Are you seeing a chi-square test?
Yes, sir. Yes, sir.
No?
Yes, sir. Yes, sir.
Okay, now you see chi-square test. Chi-square test, what do you call it? It calculates the difference between the observed distribution versus expected distribution. So expected, because there are 14 cases, and theoretically you expect that 7 people should say yes and 7 people should say no based on the equiprobable hypothesis. But now our responses are 5 and 9. 5 of them said yes, mobile should be banned, and 9 of them said mobile should not be banned. So whether there is a difference in those frequencies. Now the chi-square value is 1.143 and significance is just 0.285. That means there is no significant difference between the frequencies of 5 and 9. So though 5 and 9 looks with a difference of 4, they are statistically the same. So that's the idea where we can use a chi-square test for a large number. But again, if you want to see the commands, I would repeat the command. From the menus, choose analyze, non-parametric tests, and legacy dialogues, go for chi-square test. And there you highlight the variable which you want to require. So here the ban mobile is our variable. I highlight that, click OK. You get a chi-square, what you call distribution, number of values to be distributed, expected, and our statistics. So this is a simple chi-square. Suppose I want to generate a cross tabulation. Suppose I want to generate a cross tabulation and generate a chi-square. So the commands are slightly different. So you note down the commands to generate a cross tabulation and a chi-square. To note down the command, you have to highlight, or from the menus, choose analyze, go for descriptive statistics, and go for cross tabs. Again, I repeat the commands. From the menus, choose analyze, go for descriptive statistics, and go for cross tabs. So click that. Now it asks where you want to see the columns, which variable, and which variable you want to see as gender. So I highlight gender as in the column. Ban mobile is in the rows. How is their responses? Then I go for a cell entry. I want already by default observed what you call cell entries are there, but I want percentages in column wise, each gender wise. I'll continue. I'll explain this again, but I need some statistics. What that statistics is, I need a chi-square which is available in that prompt. So I highlight chi-square and I click continue. Then I say OK. Now you see, earlier we saw that totally 5 members were said yes, mobile has to be banned, and 9 members have said mobile should not be banned. So on an average 35% said yes and 64% said no. Now see the what you call bifurcation. 20% of males, 40% of females, and 50% of transgenders indicated yes, whereas 80% of the males, 60% of the females, and 50% of the transgenders said no. And your chi-square test down says that there is no significant association. The pattern of responses are the same. The pattern of responses are the same for male, female, and transgenders. So you say gender has no influence on the responses. But now slightly I'll change. I'll go to the screen share. I'll go to the main data. I slightly change the data part. I say all females are telling no, mobile ban. So I regenerate the analysis. Still it is not significant. So I still go for more what you call significant results. See now again I regenerate. I slightly change the data format. So I share the results. Okay, now I made the results out of 5 males. All the 5 males said yes. All the 5 females said no. But 50% each of transgender said yes and no. Now it says there is a significant association between gender and their responses, where males are more for banning, females are more for not banning, and transgenders have got 50-50 responses. So that is not an important issue for transgenders, but we are definitely, we can say males are supporting significantly more for ban of mobile, whereas female students are not supporting ban of mobile, which is highly significant. So this is how you have to go step by step. As I said, we cannot do SPSS in 1 hour. You can keep on learning through YouTube videos. So this is where a few of the glimpse on how to do statistics, having some theoretical background. So my sincere request is, before you start working on any statistics, please read the theory behind that. And once you understand the theory, then you understand the process behind it. Once you understand the process behind it, you can do easily through the software and explain the interpretation in detail. So that's the idea, and that's where we are going to stop our session now. So next few minutes, if you have got questions, you can ask quick questions. Anybody's having questions, please feel free to ask. I know this is a bit technical, but you can learn. Any questions? Okay, if there are no questions, vote of thanks.
Sir, can you audible, sir?
Yeah.
Sir, can you audible, sir?
Yeah, I'm audible.
Yeah, sir. Really, when we start with the yesterday onwards, today also it's the hands-on experience. Really enjoying the session, sir. I don't know. I personally, I can attend with so many hand-on experience in Karnataka State Open University and University of Mysore, and I personally know that, sir. But really, the past 2 days, really enjoying with all the experience. Just to come to an SPSS, really enjoying the fantastic your sessions and everything, sir. On behalf of the coordinator of HRDC and the director and all the participants, and thank you very much, sir. Your wonderful sessions and exploring your knowledge. Thank you very much, sir.
Okay, I have given my email ID. So if you have got any clarifications, you can still write to me. So no issues, I can answer them.
Sir,
Thank you,
one more request, sir. Lancy, sir.
Yeah.
Sir, please share your PPTs through particularly HRDC or your personal.
I have already given to HRDC all the 4 PPTs.
Okay, sir.
So I think they will share in turn. And if you want directly to share, you can send me your WhatsApp or any this one. I can share my all the PPTs which are presented. If you want personally also, I can give. No hidden this one. All the PPTs will be distributed free of cost. No charges.
Yes, sir. Yes, sir. Yes. Thank you very much, sir. Thank you very much,
Okay,
sir.
okay.
Sir, one